Hello everyone, this is my presentation on azidothymidine and how it is used for the treatment of HIV or AIDS. First we're going to do a little overview of HIV just to learn how it works in the body. So HIV stands for human immunodeficiency virus. It is a pathogen that attacks the human immune system, and it's a virus that can cause a slow progression of the disease. And this categorizes it as a retrovirus, more specifically in the subcategory of a lentivirus. It's a retrovirus because it works in a back-to-front way, storing its genetic information in RNA instead of DNA. So in order for it to enter a human cell, they have to make new copies of themselves. It's a spherical virus with an outer shell covered in spikes called glycoproteins. These glycoproteins, GP120 and GP41, allow HIV to attach onto the CD4 receptors, onto the CD4 T cells in the human body, which allows them to enter the cell and then kind of take over and start making new copies of itself. And as you can see over here on the side, I have a little picture of what the molecular structure of HIV looks like. So these are those little spikes or glycoproteins that are on the outside of it, and then you have some proteases, the GP120 and GP41 right here, which is what allows it to attach to those CD4 receptors, and just a little bit more about the structure of what it looks like. HIV is able to evade the human immune system. It can be controlled by antiretroviral therapy, but it can't be completely removed from the body because of its ability to evade the immune system. It's able to integrate itself into the human immune system by DNA, and it only replicates when an infection stimulates the cell in the human body to respond to that. These cells are then considered latently infected cells, and they're unable to be killed off because they're not recognized in the body as an infection. They've taken over the cell and integrated themselves into the DNA, so that way the body cannot recognize it and kind of send an immune response in order to kill it and get rid of the body. Because of this, these cells cannot proliferate without being activated, and HIV can pass between cells within tissues, in the gut, and other reservoirs. They're not suppressed by antiretroviral drugs before infecting other cells, which is how they also evade the immune system. HIV forces the cell it invades to make copies of itself using enzymes, and when these enzymes are inhibited, the production of HIV is slowed. And over here on the side, you can see just a little picture of what a cell in the human body looks like when it's being infected by the HIV cells. Azidothymidine, or Retrovir as it's known as, is a drug that belongs to a group called nucleoside analogs. It interferes with the enzyme reverse transcriptase, which is how HIV infected cells are able to make copies. AZT reduces the enzymatic activity, causing the infected cells to produce less copies of the virus. It has to be used in a combination of other anti-HIV drugs in order to be effective. By itself, it doesn't work as well. When you put all these drugs together, it's an antiretroviral therapy, and the other drugs normally in this therapy are protease inhibitors, and they can also include non-nukes, which is non-nucleoside reverse transcriptase inhibitors, which again, that enzyme transcriptase is what the HIV cells use in order to make copies. And over here on the side is just the structural compound of azidothymidine and what it looks like. AZT can also go by the generic name Azidothymidine. It's a dideoxynucleoside compound where an azido group has replaced the 3-hydroxy group on the sugar moiety. This modification prevents the phosphodiester linkages from forming, which are needed to complete the nucleic acid chains. This compound potentially inhibits HIV replication and acts as a chain terminator of viral DNA during reverse transcription. And again, that reverse transcriptase is what HIV is using in order to make copies within the cell so that it can evade the immune system and kind of hide within those cells, because there's no immune response that is activated in order to attack those cells that are being infected. So it's able to kind of hide and move within the body by making copies of itself continuously in order to kind of hide within the body. With this therapy that is introduced into the body with azidothymidine and the other antiretroviral therapies that are introduced, it can improve immunologic function, and any kind of neurological dysfunction that is induced by HIV can be partially reversed, and other clinical abnormalities associated with AIDS can also be improved. So on the side over here, I have kind of a diagram that shows how AZT is introduced into the body and how it reacts with the other molecules, so that way you can see how it attaches there. And then down here where the reverse transcriptase is where it attaches to, and that's how it breaks that down, so that way it inhibits the enzymatic function, which slows down the copies of HIV that are being made within the body. And again, this does not remove the virus from the body. It's already infected its cells. It's already integrated itself into the DNA of these cells. So again, there's no way to completely remove it from the body, but it can be to the point where it is not as detectable within the body, but that does not mean that the virus has been completely eliminated. This drug is just to help kind of slow the progression of the copies that are being made, and also kind of help alleviate the symptoms that are being caused by it as well. Thank you for listening to my presentation. I hope it kind of gives you a better understanding of how HIV works and how azidothymidine is used in the body to help slow the progression of the disease. And then on this last page, I just have the sites that I used in order to get this information from. Thank you.